And then I'm going to let everybody in. Yeah, about 60 people actually accepted your.
So hear me now?
Yes, I can. Yeah. And thank you very much, Hani, for accepting to give this talk. It's definitely a very attractive topic.
Can you hear me?
Yes.
Yes, Hani. Yeah. Hi, everyone. We are going to start the meeting in 2-3 minutes.
Hey, Hamid, the participant number is fairly stable now. Should I go ahead?
Of course, yeah, go ahead.
Hey, everybody, I want to welcome you to the 18th talk that PetroLearn is running at its PetroLearn at Home seminar series. The main purpose of the series is to keep us informed, involved in learning new things while we're all largely sequestered at home. Most of us still because of the COVID. I'm really pleased to have Hani Elshahawy from Shell as the speaker today, who in just a couple of minutes will be talking to us about real-time monitoring and control. The future is now. In order to help the presenter and preserve the bandwidth, if you'll all turn your sound off, mute yourself, and turn your video off as well. The way that we're going to do this is if you have any questions during the talk, just use the chat facility, which you'll see at the bottom of the software. It's right in the middle. And type in a question for everyone. And at the end of the seminar, we'll go through these questions with Hani, and as time permits, he'll be able to answer quite a few of them. Our next seminar is on June 12th by Joseph Batir from SMU, and he'll be talking on heat flow calculations using various thermal data sets. If you're unable to stay for the entire meeting, or if some of your colleagues were unable to come today, this is being recorded. And by the way, the first 17 of these webinars have also been recorded and are available on our website for easy playback. So again, it's a pleasure to introduce Hani. He is the Deepwater Digitalization Lead and the Principal Technical Expert for Formation Testing and Sampling at Shell, where he has spent the last 16 years. Hani was previously in charge of Shell's Game Changer program, served as Deepwater Technology Advisor and Capability Manager, and led FEAST, which is Shell's Fluid Evaluation and Sampling Technologies Center of Excellence. Prior to joining Shell, he spent 15 years with Schlumberger in over 10 countries in Africa, Asia, and North America, during which he held various positions in interpretation, consulting, operations, marketing, and technology development. Hani holds several patents and has authored over 150 technical publications, which is really impressive. He was the president of SPWLA from 2009 to 2010, and he is the recipient of multiple SPE and SPWLA awards and has been a distinguished lecturer for both societies. So PetroLearn is proud to give you Hani Elshahawy, and thank you so much for coming and doing this today. It's all yours.
Thank you, Alan. Really privileged to be here. Just want to make sure you can all hear me all right. And you can see my desktop. Can you confirm, Alan? All's good?
Yes, Hani, we do.
All right, very good. Thanks again for the opportunity. So what I want to talk to you about today is this concept of real-time monitoring and control, and you know, how relevant it is at present and how critical it is to the future. So as you can see in the title there, the future is now. And what it is in essence, before we begin, and just really in a nutshell, is very simple actually, and it's not fundamentally new, but it is particularly relevant now more than ever. It's really what I wanted to emphasize here. So it's about the ability to see stream data in real time, be able to monitor not just the data, but actually the operational heartbeat of your ongoing execution, be able to control the outcome of your execution or your operation, and be able to do that remotely. Okay, so why is that important? Because of course, in this day and age, and particularly in this COVID-19 world we're in, and God knows how many of these we might be anticipating over the next few years, you know, the ability to execute, to monitor, control, gather insights, and influence operations, and be able to derive, you know, useful insights from that, and make decisions based on that, anywhere and any time, is critical. So it's about decision making, about optimization, about integration, and more importantly, about collaboration, which is really a higher level than integration. I mean, we've been doing a lot of integration in the past, but a lot of it has been sort of stepwise, serial, and across silos, whereas collaboration, I like to think of it as a higher form of that, one which sort of dilutes those silos and you know, looks more end-to-end. In order to be able to do these, we really need to invoke real-time monitoring and control. So I'm going to talk specifically about the variant that is used in wireline logging operations, but I really invite you to think about this as a concept, broadly applicable to many, many things that we do today, from health to space exploration or underwater exploration, you know, deep water exploration, to subsurface exploration, to any other collaboration processes that we have. It's kind of really at the core of digitalization. So let's step back a little bit and talk about digital. You know, I think unless someone has been living in another planet or in a cave or something, you would have definitely experienced how digital has disrupted some deeply rooted industries over the last few years. And in fact, during the current crisis, you see acceleration of that disruption. Think, for example, what is happening to the retail industry, to the classic restaurant industry. It's quite profound, actually. So the name of the game has been disrupt or be disrupted. And really, you can think about it. It's not that change is new in all this. It's just that change has accelerated a whole bunch. So the pace of change, the rate of change of technologies, of the onset of new business models as a combination of those technologies and how they're implemented is what's accelerated. So change is a given, but the rate of change is what's changing now. So for example, you will be aware of how Uber, Lyft, and its some of their Chinese brethren have completely disrupted the conventional transport business, taxi transport business. But what's even more interesting is that Uber, you know, being the largest taxi company in the world, actually owns no taxis. And Airbnb, until recently, the world's largest accommodation provider, don't know how that will work out in the future, has disrupted, you know, that traditional real estate business without actually owning any real estate, and so on and so forth. Netflix, another example that many will be familiar with. Although, of course, they have now delved into making content themselves. But the important thing is, you don't have to actually own physical real estate. You don't have to own physical assets at all to actually disrupt a business completely. And this is quite profound because particularly for asset-heavy industries such as oil and gas, this is both a huge opportunity for the non-incumbents and a frightening concept, actually, for many of the incumbents, whether they be large, you know, operators, integrated service companies, or what have you. And so they have to really think about how do you position yourself in this world. So digital, probably along with energy transition, are two of the biggest disruptors, two of the biggest vectors of change that anybody in the oil and gas business will have to deal with over the coming decades. And what's just happened here, kind of the you know, COVID-19 and and the oil price slump, and of course the recession that we kind of find ourselves in, are all accelerations actually of those disruptions, in my opinion. So what's been happening and what will now accelerate is that digital will continue to shape the energy system. As I mentioned earlier, not just digital, but really digital is one of the major disruptors, the major game changers, along with energy transition, which I alluded to earlier, and with that, the shifts in demographics and consumer behaviors, which might actually accelerate also as a result of that. In addition to that, has been the technological change, or as I guess catalyst to those changes. So the cost of sensors, for example, has fallen steadily over the last decade, and so has the cost of bandwidth, for example, falling by a factor of more than 40. The cost of processing power, the cost of storage, cloud has been by itself a major game changer. And so all these combined, along with the changing landscape, has really contributed to this reshaping of the energy system as we see it today, and as it will continue over the coming years. One interesting other phenomena that's been ongoing as well is, really the realization of this, how do you become more data-driven in whatever business that you do? Okay, whether it's from running, basketball or football, or soccer, even for that matter, gaming, to understanding consumer behavior in retail or digital health, or more recently in oil and gas. This data-driven world, as I show below here, is one which is always on, sort of like your refrigerator. You don't switch it on and off as you go. And I guess most people now have their internet on all the time. So think of this data-driven world as being continuously on. It's always tracking, it's always monitoring, it's always listening, good or bad, and it's always watching. And ultimately, it will also be always learning. And that's really where AI and machine learning and such come in. Oil and gas has been somewhat behind in this. So I would say, this digitalization has taken leaps and bounds in earnest in the last decade or so, but in oil and gas, probably it's caught on maybe only in the last 3 to 5 years, and accelerated really only in the last couple of years. So it's really on a major headline in any large operators or large service providers strategy is digitalization. Really the buzzword. But if you look at other industries, we've seen exponential advances. So think of, for example, in computing. This is a picture of IBM's first computer using punched paper tape. I don't know if many on the phone have ever actually seen any of these. I have, but for a very brief time actually, before we transited to mainframes. But 1944, IBM first computer. There's more power packed into today's Apple iPhone X than this, monstrous, very expensive artifact that you see here. Think of manufacturing. This is what garment manufacturing looked like 100 years ago. This is kind of what it looks like today. There's not a lot of people in here, are there? There might be a couple in a control room, but that's about it actually. And that's across manufacturing in general, whether it's auto manufacturing or other. Now, meanwhile, in oil and gas, the attitude has been a little bit more, shall we say, conservative. So here's drilling in 1944. Here's pretty much drilling today. Not drastically different. But okay, so that's not entirely fair, because there have been advances actually. I mean, so this is what a driller's console looks like. Very different actually than when I started my career, something like 33 years ago. It didn't look like that, and there were a lot more people on the drill floor, for instance. And on the remote end, you have, for example, real-time operating centers with lots of dashboards and people looking at those remotely from shore. So that's great, but I would challenge if we really exploited digitalization to its true potential. Because are we truly leveraging all the data as opposed to certain subsets of the data contained in the silos that we traditionally have lived in, whether it's drilling or petrophysical analysis or what have you? Are we doing so in real, or if not necessarily real, but relevant timeframes, so that we're making decisions as a consequence of these? Or is this more passive? So there's a very big difference between watching stuff and actually monitoring and controlling stuff. And the control aspect is very important because that's what actually makes a difference in the outcome, in the decisions that you take. And so we're not really doing a whole lot of that yet. Are we producing more accurate predictive models as a result of this integration? And importantly, are we making better decisions as a consequence of that? That is still a journey to be had, I would advocate. Having been involved with digital in the last 2.5 years or so, quite heavily actually, across the board, and it's not just one organization, but it's really across the board in oil and gas, there's been a lot of advances. A lot of it I would label in the digitization, taking something that is, paper copy, for example, or an old log and digitizing that, making a digital version of that. There's some attempts to go towards digitalization, which is really about transforming the workflow. But we got a long way to go to digital transformation. Digital transformation is really some of the examples that I showed you much earlier, which is changing the way you interact with your customers, with your suppliers, with internally between your teams. It's really transformational in your business models. And we've got a long way to go before we get there. But one important enabler is going to be this concept of real-time monitoring and control. So digital enablement, which is probably a more accurate depiction of what's going on in the oil field right now, whether it's the digitization or digitalization realm, begins with data. So you would have seen, for example, this cover page from The Economist, popularized through many presentations, which is, data is the new oil, or, data is the world's most valuable resource, no longer oil. But that is both accurate and probably insufficient, because data, just like oil, maybe that's where the analogy really stops, is the raw material of this fourth industrial revolution, if you really want to think about it that way. Same way as agricultural lands used to be, as steel and raw material used to be, and now data is that raw material. But you have to refine that raw material in the same way that you refine oil and gas into useful products. And the useful products is really going up this, pyramid or hierarchy of insight. So you go from data, information, knowledge, and action. And it's with the action, the decisions and actions is where the value actually gets delivered, not with the data itself. So there's no inherent value in the data. There is residual value that you could extract, or you could never be able to extract. The trick is to go from data to information to actionable insight, and then to decisions and actions. And as I will show you hopefully later in some of the examples, real-time monitoring and control is a key mechanism to be able to do that conversion. It's key to closing open data to action loops. There are many of those open loops in our business, meaning a lot of our processes were designed from the get-go to be very linear. So for example, in the well planning, well delivery process, in hydrocarbon maturation process, in project delivery process, they're all designed to be linear processes. Some groups do some task and then hand it over, so to speak, to another group. And then there are the checkoff points, there are, technical assurance, stage gates, and what have you. However, one major goal of digitalization is to actually close that loop, to make the process more circular, more of a virtuous cycle, if you like. And one of those virtuous cycles is going, as I mentioned earlier, from data through insights to action. So this is, the sensing, decision, action loop. And in some other industries, for example, they call this the OODA loop. But it's all about these open loops that need to be closed, because only by closing those loops, by taking the data and transferring to action, observing the action, acquiring more data, but this time with the learnings gathered from your previous cycle, can you get this continuously improving expertise and efficiency in your process. And this is all processes, whether it's a well drilling, well delivery, in general, or again, hydrocarbon maturation, project delivery, even the production side of your hydrocarbon maturation cycle. Also, you can incorporate this continuous improving cycle. And that's being done elsewhere. So it's not like we're just dreaming this up. In fact, it's not that new. As I mentioned, for the last decade or more, there's been a lot of that. So for example, here I show the robotic geologist. There's no little geologist hiding inside any of these Mars rovers, for example. The reality is, this is roaming, the surface of Mars with a lot of instruments that are lab-grade instruments. So for example, it's including thermal emission spectrometry, including other spectrometers to look at iron-bearing minerals. It has an X-ray spectrometer for elemental analysis of the samples, and so on and so forth. And all that is communicated back to Earth, using a network of terrestrial antennas plus 2 spacecrafts that orbit Mars in order to send back and forth, and that's important, back and forth, has to be bidirectional, the data back and the control signals to the rovers. Similarly, of course, in warfare, well, I hate to elaborate about that, whether it's terrestrial or airborne, robotics are, of course, the default mechanism these days in warfare. And even at a higher level than that. So this is an example of real-time for megacities. This is one of the biggest cities in the world, actually, most populous, Rio de Janeiro, and where IBM has implemented, for example, its smart cities concept. And this is not completely new. This is 2012 or so. Basically you have these, gigantic dashboards monitoring essentially the entirety of the city, what's happening in the favelas and what have you. This was used during the World Cup, and of course, in times like we're in now, this is absolutely instrumental to maintaining, health, safety, and operational readiness in a mega city of this size. So this is being done day in and day out in other industries at scale. So why isn't we doing more of this in the oil field? Well, we have actually, in a way. So the example I wanted to share here, and again, it's not completely new, but I think what's new is going forward, you're going to be seeing lots more of this in other fields. In this case, this is a publication of mine that I reference here, 2005. So this is 15 years ago when we started really implementing this model of real-time monitoring and control for formation testing. And even though the title doesn't say control, but that's implicit in how we do this. This is not a talk about formation testing, so I'm not going to elaborate here, but for those of you unfamiliar with it, formation testing really is the ability to take pressures and extract samples and make other measurements, such as, for example, permeability assessments in real time using a wireline conveyed tool. Pretty sophisticated tool. So unlike a lot of other logging tools, formation testers are more like a Mars rover than they are like a camera. So think of conventional wireline logging is, you're gathering data, but there's not a whole lot of control that you have to do apart from open a caliper and, log up or something like that. But with formation testers, it's different. Actually, 90% of the interactions are command and control things, open valves, closed valves. There are hundreds, if not thousands, of moving parts in those tools. So they are very much like a remote robot, much more than they are like a camera, for instance. And it's fairly critical operation, at least in high capex projects. So a lot of the stuff that I used to work on and still do are in exploration and appraisal, mostly deep water, but large LNG projects or gas to liquid conversion projects and so on. So for these, formation testing provides answers that are related to volumetrics, For example, your shrinkage factor comes from analysis of the samples that are gathered, deliverability through the permeability measurements, a lot of completion related parameters, a lot of topside design parameters, because you have to design for waxes, asphaltenes, and other solids onsets. Facilities design, because again, it has to be related to your gas oil ratio, your shrinkage factors, and the rest of that, and valuation, because actually the properties of the crude determine the valuation. So pretty much impacting the full value chain of oil and gas. And it does that by gathering pressures, gradients, defining gradients and contacts through those pressures, collect samples of the formation fluid as well as brines. Downhole fluid analysis, you can also do it in situ and use that to enable the sampling, but as well as to get an idea of the vertical and lateral distribution of the hydrocarbons, how connected or disconnected your reservoirs may be. Permeability measurements, as well as in situ stress testing that could also be done using packers. So lots of things you can get, but it's not a set formula. It's not like you can send the tool down and say gather all that stuff at some preset kind of program. No, it's actually very interactive. And like I mentioned, 80% of what goes on is commanding the tool to do different things in different sequences that depend on the objectives, depend on the circumstances, depend on the data encountered, depend on a lot of things. So some of the examples that are encountered, and again, these are detailed in the paper, during formation testing, and so call these maybe micro decisions, if you like, are things like, have adequate pressures and samples been collected? Adequate based on the criteria that have been set a priori and the critical success factors for the well, or what have you. What is the best place for sampling? You can have some prior ideas, but you would have to revisit those based on the pressures collected, based on the actual encountered circumstances, and so on. During the sampling, is the flowing pressure greater than your saturation onset pressure or solid onset pressure or not? Because if it's not, actually you will get a biased sample, which can lead you to erroneous conclusions, which can be catastrophic actually during the execution phase. Mud contamination, is it low enough? That's important because that's a big influence on the usability of those samples. Is this the time to capture the sample? How is downhole fluid analysis progressing? What does it tell us about the reservoir? Are the pressures, because you can also perform pressure transients, are those pressure transients stable? Have you reached infinite acting radial flow or equivalent, or haven't you? Do you see reservoir compartmentalization? And if you do you need to collect more data? Do you need to reiterate? Do you need to revisit some of those, and so on? So it's not exactly a crystal ball, and it's not exactly a straightforward journey, but it's sort of interactive, and I have here a little bit of humor infused. It's all the surprises that you have to encounter and how you deal with those surprises in real time that matters a lot. So to sum it up, real-time monitoring and control of wireline logging operations beyond formation testing can learn a lot from some of the learnings that we've already had in the realm of formation testing, because it's very interactive by definition. But what we're advocating today is that we should do more of that for all logging, really. There's no reason why we have to continue to send, for example, a number of people to the well site just to gather data. We can do a lot better than that. Not only can you send less people, you can actually automate completely today with today's technology most of the logging operation. And so you can have at maximum, 1 or 2 operators. All your skilled staff can be in the back office. That is something that can be done with today's technology. It actually could be done 10 years ago with the technology, but there is more rationale, there is more impetus for doing that today. The requirements are quite simple: secure web link, usually with some encryption, minimal delay. Seconds are okay. Similar to video conferencing, for example, you don't want 5 minutes delay. You can have a couple of seconds. It's not gonna, be problematic. Bidirectional, because it has to be the monitoring and control aspect to it. It has to handle numeric plus contextual data. Why is that? Because the contextual data can become very important later on for machine learning, for enshrining the learnings and other things. Benefits are obvious: travel and logistics. course, no more than now is it clear that those kind of benefits, as well as the HSE and personnel security, are more relevant now than ever. But they've always been important. They're just very visible right now. But also importantly, decision making when it counts, which is essentially real time or close to real time. And very importantly, to interdisciplinary collaboration and knowledge transfer, because the way we've traditionally done things just doesn't allow anymore for proper knowledge capture and collaboration. You know, there's very serial ways of working with fewer people, and trying to do that faster just doesn't work. We have to do things differently. So what's new? What's new is, of course, now we've got a major disruptor, which is COVID-19. It's also a true game changer, I'm convinced, in the sense that it's really forced industries to, think about business continuity, think about resilience differently. So it's not just about efficiency, but also about how resilient you will be. How can you maintain and keep, working, and keep your workforce safe and healthy while sustaining your critical activities. So oil and gas must really adapt our operating and business models to reduce the people on site and the physical interactions between them. And this is not just, for a few months. I think this is here to stay for a long time, because who's to say, there will not be any number of future recurrences of this or any other viruses. But really, it's also beyond that, as I will explain earlier. It's really, there's some fundamental reasons this should have been done a long time ago anyway. Minimizing personnel on offshore installations. Why do we continue to have that many people operating offshore? The holy grail of demanning or reduced manning of installations has been around for 20 years. There was just not a compelling reason why it needed to be done now. Well, now there is really a compelling reason. Yeah. So, the idea of a low-touch economy, for example, is now evolving. And, how can you, in everything you do, minimize low touch and low interactions and so on. And so you can read more about that actually in this website here. Board of Innovation talks about this concept of low touch economy, which I think is very relevant at this point. And then, of course, there's the other game changer or the other disruptor, which is oil price. Again, this is probably known and obvious to everybody who's, who's in the oil field. Luckily, now oil price has been creeping, to some, respectable levels, and hopefully stays that way. The truth of the matter is, there's already a lot of damage that's been done to the oil industry that's probably staying with us for several months, if not years, unfortunately. And there is also the damage that's been done, because of sort of the exuberance, I might say, in some of the producers, particularly in the onshore U.S. market. And there were signs of stress even before COVID-19 and before this collapse, but this, of course, accelerates those trends. So we're probably going to see a recalibration, of those production volumes and so on. So both of those have really propelled and accelerated what was already ongoing. So that transition from physical to digital in pretty much every industry, that transition towards, a more diversified energy portfolio, and a lot of the things associated with that have already been ongoing. They're just going to accelerate a lot now. And part of that is to be able then to play into that, to enable digitalization to really go beyond just digitization towards transformation. Real time can enable that, and can enable that by improving integration, collaboration between different technologies. So for example, information testing, we were incorporating mud logging technologies, mudcast logging technologies, incorporating downhole measurement technologies and advances in the downhole formation testing hardware, with advances in lab analyses. And more importantly, the integration of all that to construct a more holistic, more collaborative puzzle is enabled by digitalization, and vice versa. If you don't do it, then you're really not realizing the value of digitalization. It's also improving the collaboration between various disciplines and across the life cycle, all the way from, in our case, between exploration, through appraisal, through development, all the way actually to decommissioning. And that's how I think we need to think and leverage this real-time monitoring and control workflow as an enabler for that sort of collaboration, more than anything else. Now, just a couple of last thoughts on how this is evolving lately. So a couple of new things. One of them has to do with evolving capabilities in terms of increasingly proactive workflows. So you want to go from raw data to all the way to insights, as I mentioned. And there are different types of insights. You go essentially from traditionally what we would have done is what we call hindsight. So it's really describing what has happened. And that's really quite reactive. What you want to go towards is being more proactive, as in the whole, the Holy Grail is to be prescriptive, meaning what, how can we make it something happen? You're ahead of it. So that's foresight. So you go from hindsight to insight to foresight, and you really progress that way from what I would call descriptive to diagnostic to predictive, all the way to prescriptive. And as you do that, you create more value, because you go from just the data itself, which is the raw material, as I mentioned earlier, through to the knowledge gathered from that, all the way to optimization action, which is really where the biggest value is delivered. So you can apply that framework to just about any workflow that we have, whether it's pore pressure prediction, frag gradient monitoring, whether it's well delivery, whether it's production monitoring, whether it's wireline formation testing operations, whether it's any logging operation for that matter. That framework applies. You want to make it more proactive. And then the other sort of evolving trend is to migrate as much as possible of the decision making to the edge. And the edge basically is the edge of your cloud, if you like. The edge is being closer to the acquisition point. So for example, if your well site is here, this is your edge. And so traditionally what we've done is, we've connected a lot of remote workers, and we can do that with today's technology. Where the trend is becoming is to actually push some of the simple, monotonous, repetitive tasks that are not in themselves value adding to the edge. So you can actually do it here. You can do some of the data aggregation, some of the data cleansing over here. If you're doing machine vision, for example, there's no need to send a whole bunch of video data over the internet and then process it locally and then figure out what to do with it. You can actually do the processing right there. You can build it into the hardware, in fact. So, the concept of migrating things to the edge requires that you do local computing and storage at the edge. You still have bidirectional communication, of course, but you can take autonomous action. And then you can incorporate some analytics and AI over here. Not all of it. A lot of it might still have it you still have to have it in the back end, but some of it can go here. Okay. And this is a prediction from the IDC, is that by 2021, over 40% of data generated in oil and gas production will be collected and orchestrated at the edge. By 2022, that's only a couple of years from now, 75% of new assets will be deployed with some self-diagnosing and some self-healing capability. So this is a major, major trend also that we need to be cognizant of when we talk about real-time monitoring and control. The last one I want to talk about, evolving capabilities, is incorporating AI in the mix. So as you migrate to the more cognitive realm, we start to then to look at, not just the simple version, which is sort of cognitive robotic process assistance, which is, just automating the simple tasks, like, for example, recognize when a pressure is stable, or give me an alert when, the tool has unset or something like that. That's simple. That can be done today, although it's not done often enough, but really go beyond that in machine-based process executions, meaning, involve some judgment in the process. And that includes, for example, incorporating natural language processing, looking at the context in which decisions were made, why were they made, and then evolving sort of a learning system as a process. We're doing some of that actually already. For those of you who are interested, I can share a recent publication on that. But to me, this is really pushing the boundary now, because now you can have the software essentially learn the user instead of the user learn the software. And also you can develop tools to aid the learning organization of the future, because the traditional ways of just one-on-one mentoring and people just reading library reports and all that is just not sustainable. The data and the information multiplies much faster than our ability to consume all that. So we need just-in-time intelligence, if you like, and this is really where I think we need to go, and this is what's really transformational in my opinion. So we get to this concept of the intelligent enterprise. So in conclusion then, I'd like to sum it up here. The advantages of real-time monitoring and control and remote operations includes several of the things we talked about. Implementation of best practices where competencies are not available, cost and risk reduction by optimizing personnel utilization and decreasing the number of people in the field, so you can decrease the exposure and obviously improve HSE. The ability to deliver under socioeconomically stressed conditions such as the one we find ourselves in now, optimization of personnel utilization, reduction of the people on site, and more effective deployment of new technologies by involving product owners, subject matter experts, end users, etc., during the planning, execution, and interpretation stages of a logging operation. So I just used logging operation again just to illustrate the potential and power across our business, really. But logging operation is an easy and obvious one, and one which we tried and true actually, because we've done it in some of the most sophisticated logging operations, which is formation testing. And then finally, digital enablement and greater collaboration across the life cycle is critical if we are to really digitally transform. And lastly, in this post-COVID-19 world, with all the challenges that come with it, remote collaboration will become much more prevalent. In fact, I would argue it will become a must. Now, that's all I had here, and yeah, I'll stop and take any questions you guys may have.
Hey, Hani, it's Alan Cohen. I want to thank you very much for doing this. I found this to be very insightful. There were a few questions that were typed along the way, some of them from me. So I'll go through those, and then we'll engage in a process where the audience can ask you questions. Going back to your picture of the real-time operating center, and when I was at Shell, I had some affiliation with that. So now we're using machine learning and other methods in a very simple form, combinations of different log responses and data to come up with improved diagnostics that might be used for early kick detection. But right now, as in the picture, there's a human in the loop. There's somebody in there who's there, and enough coverage around the world 24/7 to look at wells remotely. Do you think we'll ever get to the stage, and if so, when that human in the loop will not be important, and we can do this truly autonomously, so that multiple sensors indicate that there is definitely an anomaly that could be a safety risk, and a control system is triggered in order to mitigate or improve that situation? Do you see that in the future?
Yeah, that's a great question, Alan. Yes, I do see that as a potentially achievable future, actually, in the not very long term. I'd like us to move really from this concept of the human in the loop to maybe the human on the loop, some people call it, which is there is still, the human is still involved in overseeing, this complex interaction of processes, but is not a bottleneck, because I think we just need to move away from, from sort of obstructing the process. And in many cases, you see that in, particularly the larger corporations, which is, there are some jobs that exist simply because there's a boundary or there is a friction. And so they are there just to, ease that friction, to take the data from here, put it there, transform it in some way. There's no doubt in my mind, these processes, just like with every major industrial revolution that has occurred before, many of those will just go away. And I think we just have to be, honest about that. So what does that mean? It means people have to sort of reimagine what work becomes. Because if the work is just, becoming a typist, well, the equivalent of a typist today will go away. There's no ifs and buts about that. But can the typist become something else, as in, data entry for example, in the early days, data entry, you know, programmer or whatever, or you know, become later on, you know, a assistant, you know, whatever. So we need to reskill people, and importantly, this I think delves to the whole issue of learning and what it actually means. I'm a true believer that learning will have to be reinvented too. The way we learn today, the way we learn, let's say, by going, you know, to a you know, get a university degree, and then, you know, whether we do, you know, an advanced degree, and then sort of accept that that will be all right or enough for the next however many years that our so-called career will be, is really outdated already. In fact, it's been outdated for some time, and I think it will be challenged even more going forward here, because in fact, all learning I think will be challenged going forward by what's happening now, which is this concept of continuous learning, you know, or learning on demand, or micro learning, or all of these combined. You know, I guess what we're doing here is a form of micro learning in a way. But, you know, so people actually, you know, continuously sort of learn and unlearn a lot of the things as they go along, and they do that much more frequently, because now, of course, change is a new constant, as I mentioned earlier. And in that context, though, yes, there are some processes that we have already done some of that could very easily take the human out of it and allow the human to go to a higher level of integration. And it's not comfortable initially, and it does mean, unfortunately, that there are some jobs that are just going to go away, but there is the opportunity to sort of reimagine some of those jobs and what they might be. And some of it's not very visible to us today. Like, what kind of job are you talking about here? You know, what do you like? There may be in the future, for example, a lot of jobs that are sort of, you know, learning consultants, for example, that whose job is to figure out what is the best way to allow, you know, newcomers to learn more efficiently. You know, how do we capture the plethora of learnings in a much more efficient way than we do today, because it's not very good today, and so on and so forth. Jobs that just don't exist today, and we cannot really easily imagine today. But I do see many processes, for example, machine vision, which is we've implemented recently, can now be encoded actually on an edge device, and you can actually do the whole thing remotely on a small USB stick-like piece of hardware, without all, you know, the work that is involved today with an army of people running around trying to do the machine learning exercise and so on. That can already be done. But we just have to let go, I think, of some of those things, because it's uncomfortable.
Well, that's fantastic. It gives us a lot of things to think about. So that this is more participative. Are there people from the audience who would like to either chat, type in a chat question, or Hamid, I'm not sure I've got control of this whole thing. Unmute themselves or raise their hand. If you're there, Hamid, what's the process?
Yeah, both actually.
I actually am able to see. I see a question here, if you don't mind. I'll take the last question.
Sure.
So the question is, given that near misses are far more common than accidents, do we want more AI systems to know when we are approaching a critical point, and that human AI collaboration is needed to avoid reaching that point? I think that's a great question, actually. Yeah, absolutely. I think some of the focus areas that I've personally had recently is how can you anticipate the occurrence of upsets? And traditionally, this has been done by, you know, just, you know, putting a lot of data in there using, you know, classic machine learning approach. So it's kind of a little bit brute force, if I may say. So you need lots and lots of data, and the data needs to cover all the possible, you know, things that go wrong. That's an interesting approach. But another approach that actually I find better is to use more of a sparse data approach, because the reality is, you know, nobody has, you know, millions of instances of whatever it is of interest in the oil field of relevant observations that are all labeled and ready to go and include every possible upset that could happen. You know, there's very, very few instances, even if it's a rotating machinery for that matter, which is operating 24 hours a day, you know, 7 days a week. You still don't have that, and it's difficult, let alone more complex and more infrequent processes like, you know, well-controlled incidents and so on. So for those, the process that we've followed is one which works a little bit more like humans work. So the human brain is extremely good at actually distilling learnings and coming up with, simple rules to deal with complexity. Say, okay, so all the things that fall in this pattern fall in that, archetype of possibilities, and this is the way to deal with it. And there's this 4 or 5 archetypes. And then what's outside of that is an anomaly, and I have to adapt my thinking to those anomalies. So humans are very good at this. And so what we try to do is actually to distill some of those rules in our workflows. So instead of just relying, again, on the sort of the brute force way of just feed every possible data, actually, we recognize that there will never be a lot of data, but we just want enough data to build those archetypes and actually use, similar to expert systems, actually, that were original forms of AI, but they're kind of out of vogue now. But I think actually there's a lot of need of these hybrid models that use rules-based judgment in addition to potential machine learning methods where applicable. But then in the meantime, as you are working, as you're showing value, you can use sparse, incomplete, and messy data, because that's the reality we deal with. And this is a way also of enshrining the knowledge of your SMEs in those rules. So it also gets them engaged and it gets them more comfortable with that change. So in fact,
I think you kind of addressed
Alan, I see Salah actually raising hand and wants to ask a question.
Sure.
And then we go back to the chat section.
Sure. Yeah, thank you, Hamid, and thank you, Hani, for this nice presentation. So many companies and startups are now pivoting toward digitalization. So in a very near future, we will see lots of tools and frameworks out there in oil and gas that they claim that we can solve these and this, okay? So based on your perspective and Shell's perspective, what would be the top 2 features for a real-time monitoring tool to be judged or to be a winning one in this competition to come?
Yeah, I think that's a good question. Thank you for that. Yeah, it's a very crowded space, of course, already, and probably will get even more crowded. And it's difficult, by the way, even for the most experienced to judge, the wheat from the chaff. What I would say is what I've seen, the biggest, let's say, impact, because again, is you have to judge by impact, right? Impact on the business, impact on the outcome. Are companies that have focused on workflows, the ones that combine sufficient amount of subject matter expertise to be able to understand the nuances of the different workflows, but also have at their repository or through their ecosystem, which is actually really the way to go, access to sort of the latest and greatest technology. But they're able to put that technology to bear in relevant workflows. So focusing on the workflow and allowing that workflow to deliver value, you kind of construct a minimum viable product around that workflow, and not getting too hung up on sort of the the more flashy aspect of hey, we just did this machine learning model and it predicts with accuracy whatever outcome. Well, if that outcome is irrelevant, it doesn't actually matter. What is more important is you use whatever combination of data virtualization, visualization, or machine learning where it matters to improve substantially a workflow. And if you can do that, then you can take those learnings from that workflow. You can show value, first of all, and then take those learnings and propagate them elsewhere. Companies that have the ability to do that will win, in my opinion. The ones that sort of get hung up on, trying to do, let's say, the more flashy variant without understanding enough what they're doing, I worry about how they will survive. Yeah.
So just reading from the group list, in the interest of time, we're going to back up. There's one from Farouk Hamza, which talks about how can the industry work towards common standards of data storage and analysis methods. And the focus there, I think, is on data standards.
Yeah, great question. There is actually, I will refer you guys to more detail on that one. But there is an effort currently called the OSDU.
Yeah.
If you're not familiar with it, please go to the website and see it. It's very impressive, actually. I mean, I was involved from day one, and I'm impressed how far it's gone, honestly. And it is about exactly that, about agreeing data standards, not just for the sort of how you read the data, but also the metadata that is associated with your time series data or your depth-based data. It's specifically focused on subsurface data, that effort. But I think there are great learnings there that could be learned from in any other part of the oil and gas value chain. There's more than 500 members now. All the major operators are there. all the major technology providers are there, or the major service companies are there. Very impressive. And I think there's a lot to be learned from that. That's exactly what they're doing.
And then there's a question from Colin Saracen, instead of reading the whole thing, which is important. He talks about making measurements and comparing them with models and continually improving the models. But once upon a time, and it's kind of a rare occurrence, an unexpected event occurs. An unexpected event is rare in the data used to train the machine learning. So how do you feel such unexpected events should be treated? And is this the key role of the human there? So we talk about the human versus the data-driven methods.
Indeed,
can you speak
yes.
about that?
Yes, yes, and yes, actually. Absolutely. I think this is a critical role of the human being on the loop to kind of look for anomalies. So you really go from a system where the human's job is to look at everything and anything and try to discern what's interesting, to, okay, let the mundane and repetitive and boring be done by the machine, and let the human focus on what they're very good at, which is really this complex analysis of anomalous situations. And so those get flagged, you know, you build on those alerts or flags. And that's exactly, by the way, what we did in the experiment that we've done, information testing, which again, I'm happy to publish, to provide the publication that documents all this. But yeah, we took the mundane parts, but still allowed the expert to be in control of the anomalies. But then also try to build some of the logic around identifying those anomalies, flagging them, giving some help to the expert by surfacing historical cases of where that has happened before. So he will come and say, hey, by the way, you know, last time I've seen what you're talking about right now, and this issue that you're talking about, it happened, well, X, Y, Z, and I can pull it up for you right now, and here's what you actually did. It's not going to take over, it's not going to control anything, it's just going to guide them to do that. But then you allow the human, again, to focus their energy where it matters the most. But yeah.
So Alan, I have a follow-up comment, if I may.
Yes.
So Hani, great talk. Thanks very much for that. So in geomechanics, as you know, we've done these closed loop methods for a long time, you know, building a predictive mechanical earth model, comparing data with the predictions, using the discrepancy to improve the model and therefore the predictions, etc. The key thing I learned from this is the importance of understanding how the model was made. So when you experience an unexpected event, because you have built the mechanical earth model and you understand the assumptions made, you can interpret the unexpected event because you understand the limitations of the model. And my question really is, if that model is a machine learning based model, you no longer have the understanding of the model. Therefore, it makes it more difficult to interpret an unexpected event. Do you have any comments on that?
Yeah, absolutely. Absolutely. I fully agree. And, you know, I don't want to discredit what people have been doing with, you know, sort of pure machine learning approaches. Yeah. Honestly, very few of them are valuable as is. Okay. Valuable in any meaningful, you know, problem. Like, for example, you know, I can show the machine can identify, you know, the difference between cats and dogs and, you know, a muffin and a cat or whatever. Great. If you have tons of these, well, where in the subsurface do you have those situations actually? So few where I've seen value. That's why I have a bias towards more classic expert-based systems, okay, that are built around rules that are sort of programmed, assisted with machine learning. So think of it as a hybrid model. And this is relatively new, but pretty much all of the implementations that I personally have been focused on are these hybrid models. So I can give you, you know, several examples, but basically think of it this way. You take your heuristic physics-based or other model-based method that you use, you know, because, you know, as humans, we have to use a model to be able to explain it, yes? To be able to get it vetted, to be able to communicate it. So use whatever that is. But then you run side by side some kind of machine learning type model, and you use that to tune your tunable parameters, if you like, but you still are actually operating based on the boundaries that are set by your model. And the holy grail eventually is to come up with, you know, again, this is a little bit of an overused term, the digital twin of your process, which is really just, you know, an evergreen model of your process, which incorporates both the model and the data, you know, the real-time data as it's streaming, so you keep refining your model. It becomes an evergreen model, and visualization. And if you combine those three elements, then you get a much more powerful, situationally aware model than traditionally we would have used. But I'm not for abandoning modeling altogether and resorting to a black box. Because even if the black box works, whenever it does work, how do you know where it doesn't work? How do you explain it? How do you defend it? How do you audit it? You know, it's just not clear to me how you would ever do that in any useful workflow. So hopefully this addresses your question, Colin.
Excellent discussion. We'll take one last question if anybody has. We're mindful of the time here. If not, I want to thank Hani very much for a very intriguing talk. We will advertise, Hani, that this talk is available on the PetroLearn website.
Thank you so much for the opportunity.
Yeah, absolutely. Very, very thought-provoking. And thanks to everyone who's attended. So the next talk that we have, which is on a different topic, of course, is on, looking at the sheet here, June the 12th, on heat flow calculations using various thermal data sets by Joseph Batir from SMU, Southern Methodist University. Thanks so much, Hani, and may the rest of you have a good, safe week. Bye.
Thank you.
Thank you, Hani.